internet available, but you know, that's just me. All right, no mouse needed.
The name of the program?
Cheese, yes.
Cheese?
And the screen capture is Kazam. It's Linux. That's what you get. All right. So any other questions so far? So let me, since we're talking ODPs, can I get to it without the internet? Okay. This is the only way I found to connect. So let me do a quick run through on ODP 301. So you're making another class. It's still named my class. And it looks very much like what we were doing yesterday when we were playing with constructors. So you're going to make this class. It contains a variable named x. It has to be a publicly accessible variable, integer named x. And when you construct, you pass an integer, and the constructor just sets x equal to that value. So this is a sample main program you could use to test your class. But you're not required to use this, right? But you would like to test your class and know if it works. So what this is doing is, right, this is our standard declaration of a main program. It constructs an object of my class, it passes 17 to it, and then it just prints out the value of the x field. And then I change that just to make sure I have access to it, to make sure it's really public. And now if I print the x field, it should give me a 23. So if you write your my class correctly, and you use this as a test program, and you run this with a Java command, right, it should print out mc.x equals 17, and then mc.x equals 23. And if it gives you compile errors or can't find the class or something, you did something wrong with my class. So once you've got your my class written, right, assess it with this line. So temp my main 301, and then my class.java. And it should give you 10 out of 10. First one was straightforward? Yeah. And the first one's funny because I'm having you print something out, and it's got to be exactly the right format, right? But in general, you're not going to be producing output from your ODPs. You're going to be writing a class that has methods and does things, and it'll be testing it sort of internally. So it won't be sensitive to differences in output.
The other one I posted, 3021.
Oh, you did that too? Okay, but you couldn't assess it yet, right?
Yeah, I can just
Okay.
So
Yeah.
we want two different outputs when we're here, or do we just need the one output when we're actually assessing it?
What you're actually assessing is the class called my class, which does not produce any output.
Right, okay.
Okay, it constructs, and it's got a field named x, and it's public, and that's it. So it's like 5 lines. It's really like 2 lines technically.
Okay.
This is just a sample main program that's testing that class to see if it works.
That sounded way more complicated in my head.
Yeah.
That's actually probably the code if it's attached by anyways.
Yeah, the README is like 20 times longer than the code itself will be.
What
All
is
right.
302 again?
How many people started Lab 1? Cool. Any major issues?
On Linux, I had to use the -s switch to change the USB that was being used.
Okay.
For Minicom.
To change the configurations of it or the name of it?
The name of it, because if you just did this, typed in the name after the command, it wouldn't switch.
Should be -D.
Dash D?
Yeah, uppercase D. I updated the lab yesterday to put that in.
Okay.
So minicom -uppercase D and then /dev/tty USB 0. Yeah.
Overclock is locked.
It's locked?
It doesn't let you do anything
Yeah,
with
it
it at
won't
all.
let us use it.
What did it say?
It said this Raspberry Pi can't be overclocked.
Oh, really?
Yeah.
Okay. You did this with a sudo in front of raspi config?
I think so.
Yeah.
Henry was the one that did it.
Yeah,
I'm
he
pretty
did.
sure he did.
Yeah, he did sudo for us.
Huh, well, that's annoying. I'm
I
pretty
mean,
sure the
yeah.
old ones let you overclock.
I thought it was weird too, because you said not to go overboard with it.
Yeah.
And then it's like, oh, I guess we can't do it anyway.
Huh, I'll have to try that. Because I'm actually using a pretty old version of the operating system. It's from 2016. Because it made the GPIO stuff work, so I'll try that later.
Yeah. I mean, we can try it too.
Yeah.
Shouldn't take
Okay.
In case you're curious, you got 2 more.
All right. If you're using Minicom, there's an option you can use also to save your configuration in a save file, so that once you do that once, you can just say Minicom, and it'll use the right device and the flow control turned off and all that stuff. Windows had at least one case where somebody needed to install a driver, and if you just Google for CP2102 driver Windows, there's a file you can download, and then in Device Manager you can point it to that, or you can run the install file. And so if it's not working, let me know. All right, so we want to dig deeper into classes today. So let's make a class of rectangles. So rectangle is just, a four-sided thing. And it's got a height and it's got a width. And it's got an area, which is the height times the width, and it's got a perimeter, which is 2h plus 2w, and so on and so forth. And we want to create a structure, right, a class, that can store the height and the width, so that we can create something that we call a rectangle, and this rectangle comes with the height and the width field. So we want to be able to do something like rect r, and then talk about r dot h and r dot w. So those are the dimensions of the rectangle. And again, if this were C and all we wanted was a structure with some data fields, that would be all we need. I'll throw a public in here just to avoid talking about defaults. So a rectangle now has a height and a width associated with it. But since we're trying to move towards objects, we probably want at least a constructor. So we're going to make a constructor. So rect so this constructs a rectangle, and now we can say something like R equals new rectangle 5, 7, and that'll set height and width accordingly.
And now you can make a new method that gets the area of the triangle.
Yeah, yeah.
Or triangle.
So let's make a main method. So I can do rectangle R semicolon and then say R equals new rectangle, or you can, just like you can say integer x equals 5, you can give R an initial value when you declare it to be a rectangle. Either way, it's the same thing. And we'll just print out its height and width. I deleted all my rectangle code. So there's the uncommented version of a rectangle. It's got a constructor and nothing else. We'll make this public.
What does the default be? We don't put public or private.
I think it'll default to public, but my knowledge may be outdated. So let's compile that up and see if this works. So we run it, and it tells us our rectangle height and width is 5 and 7. No big surprise so far. All right, so let's add some methods. So there's a method for computing the area of our rectangle. It'll give us a syntax error because I can't type apparently. And again, when we say r.area, we don't have to tell it what the height and width of r are. It already knows because r comes with a height and a width. I put this in the wrong place though. Okay, it already comes with a height and a width. That's part of the class. So when I say return height times width, it's going to take the height and the width from the class, which means if it's r.area, it's going to use r.height, r.width, right? And that's the fundamental shift from structural language like C, where we would say area parentheses r, or we'd say area and we'd give it the height and the width or something. So let's use that. So let's just print out the area. Right, and no big surprise still. And just for fun, perimeter is another method. So we've got area and perimeter. All right, makes sense so far? So let's add a more interesting method. Let's give us a method that will convert this rectangle to a square. So what does this mean? We've got a rectangle which is 4 by 16, has an area of 64. That's the same area. It's actually 16 and 4. It's the same area as an 8 by 8. And any rectangle, we can always find a square with the same area. Right? And it's not that difficult, we just need a square root. So method to square this rectangle. It doesn't need to return anything. It's just going to change the height and the width of the rectangle. So it doesn't take any arguments, it doesn't return anything. So we're going to first set area equal to the height times the width. And we're going to take the square root of the area and set the height equal to that. And we're also going to set the width equal to that. And Java knows how to do square roots, but we have to tell it where to find the square root. Just like when we wanted to say print line to do output, we had to tell it where to find print line. And the way we do that is we put math with an uppercase M in the beginning. What we're really doing is we're saying there's a class somewhere named math, and math has a method called square root. But this is going to get into statics, which we're going to talk about later on. So for now, if you want to do the square root of a number, uppercase math dot square root, parentheses, thing you want to take the square root of. So this will set the height and the width equal to the square root of the area. And it doesn't return anything. It doesn't have to, because when we run this function square, it's going to change this height and width up here. And we should end up with a nice square. So how do we square it? We just call the square method. And then let's print out these things again. The height, the width, the area, and the perimeter. So the original was a 5 by 7, area 35, perimeter 24, and then it changed it to a 5.9 by 5.9 with the same area and a different perimeter. Make sense? Now I can do something like this. Height equals width equals, and I can do my pair of assignments in one statement, just like in C. But notice what I did here. I computed the area by doing height times width, and then I took the square root of that. I already have a method for computing the area, right? It's just area. So I also could have done this. I could have said call the area method. That will give me the height of this rectangle. And then whatever that returns, take the square root and set the height and the width equal to that. And it does exactly the same thing. But this is code reuse even within just a single class, a very simple class, right? And if for some reason I wanted to have a different idea of what the area is, I only have to change it in my area method, because everywhere that I use the area, I'm just calling this one piece of code. So you want to be thinking about this sort of mindset of not reinventing the wheel, right? Even if it's your own wheel that you already made. All right, well, what else can we do? So let's change the dimensions. So let's make our 4 by 16 rectangle. And let's square it up. And then let's go ahead and see what we ended up with. And I'm going to throw some new lines in the beginning here.
So those text codes still work too.
Yeah, so you can use all the nice escaped characters that you can use in printfs and stuff. And a whole lot more. All right, so we squared it up. We took our rectangle and we turned it into an 8x8 square with an area of 64, perimeter of 32. All right, here's where it gets interesting. Suppose you got a smart aleck, and they say, I'm going to make a -4x16 rectangle because I'm evil. And now when you try to square it up, you've got this not a number dimensions going, and your area is not a number, and your perimeter is not a number. And if you're trying to use this rectangle in something else down the road, horrible things could potentially happen. It like launches the missiles or something, I don't know. Because you don't really want a rectangle with negative height or width, right? It's a goofy thing to do. And there's all kinds of goofy things that a programmer can do to our beautiful data structures. We might make this really nice linked list, and we put a delete method inside, but we assume you're only going to delete things that exist in the list. So you're going to have to call search before you do the deletion, right? And somebody might not do that. They might try to delete something that's not in the list, and they might break our code or introduce garbage into our list. So we'd like to be able to control how these rectangles are modified. And this is starting to talk about what's called information hiding. And it's one of the ideas of object-oriented programming, is giving the user access to your structure through a very controlled set of mechanisms, an interface of some sort. And we don't want the user to be able to come in and do something like, say, give us a negative height. So what do? Well, in our square function, we could check to see if the height and width are negative. And if they are, we could print an error message or something. Or we could check to see if the height and width are nan whenever we use them. And if they are, we could do something, right? But that's not really addressing the problem. The problem is the user came in and they gave an illegal value to the height or width of this rectangle. And we'd like to prevent them from doing that. And the problem is they did it right here in their main program. They said r.height equals -4. So here's what we can do. And it's really simple to fix. We can make these things private. And if we say that height and width are private, and they try to write code that's going to change it, they're going to get errors. I really got to get my mouse working. So they get errors when they say r.height equals, whether it's positive or negative. But they also get errors when they try to use the height and the width. Because if something's private, it's private for both reading and writing. So what we're saying is these variables, height and width, belong to this class, but only things in this class can modify them. Things in other classes aren't allowed direct access to height and width. But we may want the user to be able to see what the height and the width of the rectangle are. So we have to write some more methods. So we can write a pair of methods which are sometimes called getters. And it's as simple as this. So we write a method called getHeight, and it returns the height of the rectangle. And we can write a getWidth that returns the width of the rectangle. And so we want the height of R, we can say R dot get height. And we want the width of R, we'll say get width. So we're not directly trying to read R dot height. We're using a method, and the method is public. I didn't declare it public, but it defaults to public. And that method is inside this class, so it has access to these private variables, height and width. So that will compile except for the places where we try to change the value of height and width. So we also need what we can call setters.
Use a method called set height and set
Yeah.
width.
Yep,
And that's where you can check if it's negative.
that's where you can check if it's negative. So the setter is going to need an argument, and I'll just call it h.
Then you can check if h is negative or just less than 1 or 0, something like that.
So now I'm going to, instead of saying r dot height, I'm going to say r dot set height, -4, and r dot set width, 16. So now it's doing what it did before. And now we can do what you're suggesting. We can take care of these negative numbers by putting something in here which says now if they try to set the height to something negative, what should we do? We could print an error message, but you don't usually want to print things in the middle of code that the user's not expecting to produce output. So we'd probably want to set an error flag somewhere or return an error code or something. But for now, I'm just going to ignore the request completely. I'm just going to say if the height's positive, we'll go ahead and set the height. Otherwise, we're just going to ignore it. It's not great programming style, but...
Shouldn't we put an h instead of height for that?
Say what?
Shouldn't we put?
Yeah, we should put an h. Thank you. So now if you try to set the height or width to be 0 or negative, it's a no op, basically. And so it behaves nicely. So setters and getters are accessors and mutators, as they're called, if you want to sound fancy, for controlling access to private variables.
So I'm totally new to Java, I'm just clarifying something.
Mhm.
Your class is, as long as your class is in the same directory as the name, it'll pick it up?
Yes, it should. And if it's not, you can specify what other directories to search for with something called a class path.
Okay.
And you can actually say -cp and then list a collection of directories, and it'll search in those for classes.
So there's generally a large Java program that would be in multiple directories, not
Yeah.
just like one.
And it will also, we can specify these with what's called an import statement. And we can also take multiple classes and multiple directories and bundle them together into like a zip file, it's called a jar file. And then just give Java the jar file and it'll pull things out of there. But easiest way, put everything in one directory. And that'll work for now. All right, so we have accessors and mutators, okay, fundamental concept. Eclipse will write these for you. Right, there's an option you can use to say make me some accessors and mutators. It'll write the code for you and it'll comment the code for you. And it'll show up in your Java doc when you say make my Java documentation. And it may feel a little weird at first. I want to print the height, I'm calling a function, I'm calling a function, I'm calling a function. It may feel a little strange to be doing all this extra work just to print the fields in a structure, right? But there's an upside to it, which is that the person creating the class has a great deal of control now over what the user sees. Another example where you might do this, suppose, for example, you want the user to be able to set the dimensions of a rectangle in inches. Okay, suppose the units matter, and you're giving them code so they can specify the dimensions in inches. But internally, you want to store the dimensions in millimeters, right? You could take their number of inches and then multiply by 25.4, and that would be what we stored in the height and width variables. And then when the user wants to see what the dimensions are, we could take the height and width variables, divide by 25.4, and return the number of inches to them. The user has no idea that we're storing the dimensions in millimeters. The user doesn't need to know that. Okay, so this comes back to the idea of information hiding, and it comes to the idea of an abstract data type that we talked about in 222. To the user, they want to be able to construct a rectangle, specify the height, specify the width, find the area. Is it being stored as a pair of doubles? Is it being stored as a pair of floats or as a pair of integers representing millimeters? Or are we representing it in some strange notation that's only used on our native planet or what? Doesn't matter, right? All of that is completely hidden from the user. But the only way we can do that is if we have the ability to control and limit the user's access to what's going on inside our structure. If we allow the user to set rectangle.width, and they don't know that this week we're storing widths in millimeters, right? Their code is going to break because we used to store width in inches and now we're storing it in millimeters. And when they say r.width equals 5, it does something different now. So we limit their access. We have this very controlled interaction with the user and the data structure.
So what is that output you've got on your last one there? Where's all that coming from?
Because
It's all negative.
so our main program said set the height to -4 and the width to 16. So it ignored the height. So the height was still whatever it was,
Okay.
which I guess was 5, and then the width was 16. Well, it was whatever it was after we squared it up.
Okay.
So yeah, so it's 16 by square root of 35, all squared up.
Okay then.
Yeah. All right, so the following ODP, which opens tomorrow morning, is playing with accessors and mutators. So same class, my class, but you're going to create a pair of methods for reading and writing the variable x. And you're going to declare x to be private. But then you're going to have a getX, which returns the value of x, and a setX, which takes an integer and sets x equal to that. And then sample test program, construct a class of value 17, but instead of saying mc.x equals 23, you can say mc.setx 23. And instead of printing mc.x, you're going to use mc.getx to read the value of x. So you're going to augment the class you make in 301 and add this setx and getx methods. Does that make sense? So that opens tomorrow morning, and these ODPs, I'm pushing them up ahead of time, but if you write 302 and you try to assess it, it's going to be assessing 301, and you'll get like 0 out of 10. So go back and reassess 301 to get your 10 out of 10 back, because it records the last grade you got for each assignment. And then wait until 8 o'clock tomorrow. All right, questions? I missed the best part of the lecture. All right, so let's get rid of all of this stuff. And let's just play with our 5 by 7 rectangle. So we've got a height and a width, and we print the area, and we print the perimeter, and then I'm just going to print out r equals, and I'm going to print out r. Why not? Because print line will take things, and it will concatenate. So I'm printing out the string r equals, and I'm concatenating r, whatever that means.
It's gonna let you do it.
So it compiles it, and when it prints it out, it says r equals rectangle at 546A03AF. There's kind of like a memory location, right? We don't want to deal with memory locations. But this is Java's sort of internal representation of what R is. So rectangle is clearly the name of the class, so it's an object of type rectangle, and this number after the @ sign is somehow an index into some sort of data structure referring to this rectangle. And if I made another rectangle, it would have a different number after it. But that's not terribly useful. So here's what we can do. Anybody want to do a traffic load? Ooh. Flashbacks.
Oh, boy.
We can make a method called toString. Takes no arguments and it returns a string. And here's the kind of freaky thing. When we have something like this, where we're trying to concatenate an object to a string, Java will look to see if there's a method named toString in that class. So R is a rectangle. It will look in the class rectangle and see if there's a method named toString that takes no arguments and returns a string. And if there is, it will run that method, and whatever value it returns, that's the value it will concatenate. So what can we do with this? So we're just going to return a fixed string, haha. And it's going to force me to say public. Because I think the default is protected. And now when I run this and I say print out r equals plus r, it says r equals haha. Okay, that's a little better than the weird hexadecimal numbers. It's not totally useful, but we can make this thing really useful really easily. So instead of returning aha, let's return something like height followed by an x followed by the width. So what is this going to do when I try to print out R?
It'll give you the dimensions.
It'll show us the dimensions in a pretty human readable format. So R is 5 by 7. So any object that we create, any class that we define, if we make an object of that type of class, we can print it out. We can concatenate it to strings, and we can print it with print line. And in its place, it will show us whatever we tell it to show us. And if we don't make a toString method, it shows us that weird sort of internal representation of a rectangle. But we can say, hey, I want it to show us this particular string or something else meaningful. And there's actually something really powerful going on here that we're not going to get into too deeply today. But what's really going on here is something called a class extension. And I'll give you a brief overview of it for now, but we'll spend more time on it later. I've said a few times now that everything in Java is a class. more than that, a lot of the classes in Java are really variations on other classes in Java. And we might make a new class called a polygon that stores an n-sided polygon. And we might write a bunch of code in there, and a lot of that code might also work if our polygon happens to be a rectangle. And instead of rewriting all that code to make our rectangle class, we could actually take our rectangle class and say, okay, a rectangle is a polygon, but it also has these other features. And all we'd have to do is write code for these other features that are particular to rectangles. And so the image would be, here's the class of polygons, here's the class of rectangles. And the rectangles are a particular type of polygon. And we might make another class called a square. And a square is exactly like a rectangle, except the height and the width are the same. So why should we write a new area function, a new perimeter function, a new toString function, right, if it's all the same as for a rectangle? So we could make a square that's an extension of a rectangle class, but forces the height and the width to be the same. And so most of the classes that we deal with are extensions of other classes, and those are generally extensions of still other classes. And if we look at some documentation, I usually just Google Java doc. Though that doesn't bring up what it used to. So let's just look at strings. So string is a class, but it's actually a version of what's called an object. An object is sort of the parent class of all other classes. So there's another class called file writer. A file writer is a version of an output stream writer, which is a version of a writer, which is a version of an object. Which means that everything that an output stream writer has, a file writer also has, unless it's modified it. And it may also have added some things to what an output stream writer does. And an output stream writer has everything that a writer had, plus some other stuff, and maybe some changes. So this is another version of code reuse. And the terminology here is a class extension. So if you look at an object, it's a really simple class. It's got one constructor with no arguments, and it's got a few methods, and one of those methods is toString. So when you concatenate a rectangle that doesn't have a toString method that we've written, our original rectangle class, when you concatenate it with a string, Java looks for a method called toString. Even though we didn't write one in the rectangle class, because a rectangle is an extension of an object, the object has a toString method, the rectangle class has one. It inherits it from this object class. So all of this stuff is available in a rectangle automatically simply because a rectangle is an object. So it's got a wait method, and it's got a notify method, and a hash code method, and it's got a toString method. But what we did was we wrote our own version of toString, which overrides this default one. Now this default one says print the name of the class and @ sign and then that hex code. And we wrote our own version of toString, so now when toString gets called for a rectangle, it runs our code. So like I say, we'll spend more time, we'll look at specifically at extensions, we'll see how to create class extensions and so on. But that's something to keep in mind. There's this hierarchy of objects, and objects are generally extensions of other objects. And you get all of this stuff for free anytime that you extend a class. You inherit all of its stuff, basically. So that's another very object-oriented kind of concept. All right, so I'll leave it there. I want to go over PA1 tomorrow, and you're welcome to eyeball it ahead of time if you want to be ready with questions, but we'll go through that in some detail, and then we'll continue talking about objects. I'll throw this code up on Canvas, by the way, the rectangle class in the main program, so if that's useful, it'll be up there.